Okay, thanks. Let's kick this off. So I'm here to talk about cloudbursting to Amazon EC2 from a data center or private cloud using SQS. So I'll do a quick intro of me, a little bit about the background of why we want to cloudburst, what it is, kind of how it works. Talk about use cases and workloads where it makes more sense, somewhere it makes less sense, and then talk generally about solutions that you can use. And then from there, I'll move into a specific use case, which is the OpenLogic use case, which is the one I know most about, and talk about pros and cons and problems and suggestions, advice, that sort of thing, followed up with some Q&A at the end. Okay? So as we said, I'm Rod Cove, CTO and founder of OpenLogic. A lot of software development experience in large companies, small, some in between. I'm currently writing a book, Cloud Computing in Action, Innovating with Open Source for Manning, and cloudbursting is one of the chapters of the book, so that's a good fit for this talk. And OpenLogic, what we do is help with provisioning, support, and governance of open source, including SLA support on 650 plus projects. And we have a free site, olex.openlogic.com. You can go and research over 350,000 open source packages, find what you want, see what's certified, download them from us, and that's all free. We do have a lot of customers and a new cloud offering that makes it easy to get up and running in the cloud of your choice with open source stacks. Okay, so hopefully the audio will work in the room with the acoustics. We'll see how this goes. Kick it off with a little video, something I overheard the other day in the enterprise.
Hi, Bob. I've been practicing the robot. Pretty good, ha.
Hi, Kelly. Yeah, that's just wonderful. So, my application is running in the data center on a bunch of virtual instances.
Sounds good. What's the problem?
I see occasional load spikes and drops. For example, Monday through Friday from 8 a.m. to 5 p.m. is most of the activity. I get a big burst of hits around the end of each month. During spring break, I only see sporadic usage. When we have a new product launch, it gets slammed. And, of course, it's a ghost town around Christmas.
Not an issue. Just set up a bunch of VMs and have them ready to go at all times just in case.
Well, yeah, I could do that, but I hate filling out the TPS reports to justify the extra expense. Plus, it's kind of wasteful. It would be nice to just scale up or down my capacity on the fly based on current demand. But I don't want to pay for any reserved resources when I'm not using them. And I couldn't make a long-term commitment to get any of this because I don't have the budget for it.
I see where this is going. Use the cloud.
Public or private?
Good question. How many servers do you need? And disk? And bandwidth? And what's your expected growth curve look like over the next 5 years?
I have no idea. And it could all change from day to day.
In that case, I recommend the public cloud.
But I have sensitive data, with regulatory compliance issues,
Oh?
and performance and reliability concerns about the public cloud.
You don't say.
And big data, that's hard to move around and expensive to store long term. I don't have a huge budget for this.
I meant private. Yeah, use the private cloud.
They say it won't be ready for another 6 to 12 months.
Wait for it. It's gonna be great.
I have a tight deadline. Besides, I'm not sure it will scale up big enough and fast enough for my load spikes.
But we'll have hundreds of machines ready for your workload at all times. Probably.
And my users could be anywhere in the world. Can we scale globally? What about bandwidth if they all hit at once?
I meant public and private. Yeah, cloud bursting is the way to go.
That sounds just great. Thanks, dude. Catch you later.
You're welcome, Bob. Now, back to work. I have important things to do today.
Sound familiar? Anybody? Anybody have gone through the same conversation? So the idea is we want the best of all possible worlds. And the goal is with cloud computing, cloud bursting, you can do that. There's also cons, and we'll talk about those. So what actually is cloud bursting? Well, Cloud Computing Wiki says it's dynamic deployment of an app that runs on basically your assets in-house and you scale it out to a public cloud to address spikes. So that's kind of it in a nutshell. So to figure out if it makes sense for you in your use case, your workloads, I ask 4 questions. One is, can you pre-stage your data or your code out to the cloud? And the reason we ask this is because it takes time to set up. If you're going to do this burst, it's not a millisecond thing to go spin up an instance in a cloud and have it act like a virtual extension of your private cloud or data center. There's setup time. It can be minutes. It can be many minutes. So if you can preload data in the cloud, maybe you put it on S3 or EBS volume, something like that, it shortens the process. If you can't do that, but you have small data or small code, or maybe you can quickly download your code from your internal Git or GitHub, or have cached data on S3, it still might work. Or if you can host everything on a public cloud, maybe S3 is your primary storage for some of this data and code, that'll also speed stuff up. Second question is, do you need big data? Because big data takes a long time to move around. You don't have time to take terabytes and push it over to the cloud every time you want to launch a new machine or scale up or down. So if you do need big data, you could still use Cloudbursting if you don't have to have all of it all the time. Maybe you've got some data affinity or data locality kind of scenarios where you can have a portion of your problem's data out there in the cloud, or a subset of the problem you're working on. Basically, how do I narrow that chunk of data so that's something I can move faster? Maybe I have small data services. Maybe I have both a big data part of my problem and a small data, something that fits in a relational database or some more traditional storage, and I can Cloudburst that part. Right? Maybe it's a web app, for example. Third is, do you have regulatory compliance issues with security or some other reason that makes you think you can't put something outside of your firewall? Or even if that's true, you may be able to segregate your problem into data that can't leave my house and data that can. And I'm going to talk about all these in the implementations going forward in ways that you can address this generically and ways we address it at OpenLogic. And finally, are you user interactive? Do you have users sitting there waiting for you to show a response when they click something? If you do, then you have to have servers up and running. You can't have them wait for 2 minutes while you spin something up. So you can still get away with handling these interactive apps in Cloudbursting as long as you can either pre-stage because you know that, well, it's 8 a.m. on Monday. At 7:30 a.m., I'm going to spin stuff up and get it ready. Or maybe this is every other week or end of the month. You have some standard recurring job. You can sort of pre-scale just in time, keep those resources available until your job's done, and then back them down. Or some other way it's predictable, like we're getting ready to have a big project or product launch. Let's pre-scale for that. So there's ways to do both these batch and interactive jobs with Cloudbursting. You just have to make sure your use case is kind of tailored to the way you architect. So more detail on the batch. Batch side is a good fit. And here we're talking about offline processing. There's not a user sitting there waiting for an immediate answer. You're talking about, you have a good chunk of time, a few very large jobs that could run for minutes, hours, days, weeks even. And your job is to get as much throughput as possible. So you want to throw 100 servers at it, crunch through terabytes of data, and then maybe your jobs are done. So things like a giant email blast, if you want to be a spammer, analytics, BI type tools, ping-based monitoring. Maybe you've got to iterate a list of 1 million machines and go ping them, something like that. Or scanning. And scanning is one of the OpenLogic use cases. That's why I have a little asterisk, because it kind of spans both batch and interactive. So I'll come back to that. And interactive is when you've got more impatient users hitting your website, for example. When they click, they want immediate responses. Lots of very small jobs, like web apps, order processing, etc. And the focus is on performance, not throughput, because it's the user's experience that's most important. So as you can guess, it's a lot easier to Cloudburst the batch side of things because you have more time to play with. Latency constraints of the interactive jobs are just very hard to meet when you've got all this set up in overhead time. But if you can pre-stage and you can sort of overshoot your scaling, meaning it looks like I'm having a trend or I need a burst, go ahead and acquire more resources than I think I need, just in case I'm just seeing the tip of the burst. Let me over-allocate by a server, 5 servers, 10 servers, just to make sure I've got a little bit of a buffer because I don't want to keep users waiting. So there are ways to deal with that, but it's easier with batch. So the general solution overview, the concept, is we're going to burst work from our data center out to virtual private cloud on EC2, although most of the things I'm talking about will work with other clouds, public and private, as long as you've got some kind of queuing mechanism similar to an SQS, for example. And the reason why is we're going to use queues. If you're just in here at the Rabbit talk, you kind of get how that works, right? Queues are a really good way to buffer multiple systems so they can scale independently. So what we're going to do is process some work in-house, and when we need it, we're going to start throwing extra jobs on the sort of outbound queue, which is going to be SQS, and then we'll have workers on EC2 that are sort of auto-scaled based on the size or length of the queue and how much work needs to be done on the EC2 side. So that's kind of the solution in a nutshell. So the pros are we get better performance, right? Because we kind of get the best of both worlds. We have the in-house, the data center processing, which gives you the rapid performance on those local jobs. We get scalability because we can fire up as many machines as we want in the public cloud to process in parallel. And we get some cost savings because we don't have to buy all those all the time. We can burst only when we need them and shut them back down. So it might be an hour a day or a couple hours a week, a day a month, but you're not paying for everything. You also get security because you can make sure that you only process certain jobs that are sensitive in-house. You can do the same if you have regulatory compliance issues, and you have the ability to control what goes in and what goes out. So lots of good things. On the bad side of things, you have the complexity of doing both, because now you have to build both an in-house data center focused solution and a cloud-based solution. And those are slightly different skill sets, a lot of different operational issues, and you have to do both, and you have to make the two coordinate, which is even more work, and you want to do that securely and as performantly as possible. And there's complications, the setup time factor. Okay, so because this is based on SQS, let's take a look at what that is first. First, the good side, the happy cloud, right? The positives of SQS. It is persistent queuing service, so you can easily put something on a queue and they'll make sure it gets persisted, stored. It gets spread across different data centers, different servers, so they're not going to lose your message, hopefully. You can put as many messages as you want on as many queues as you want. It doesn't really cost anything to do that. You only get charged by what you actually put out there and consume, not by the number of queues. You will get the messages at least once. They won't just drop it on the floor. And one really nice thing, which is pretty powerful, is this built-in locking and retry mechanism. So when you pull something off a queue, there's a certain lock timeout. And what happens is if you process that message and don't sort of acknowledge back to SQS, hey, I fully processed this, I'm done, eventually SQS will say, well, that job that took this message off the queue probably failed. I'm going to automatically put it back on the queue so somebody can pick it up and retry it. So that's a very nice thing. It means you don't have to worry nearly as much about all the failure modes of your sort of processing side of things. And you have secure access to the queues. There's various Amazon-focused mechanisms or specific mechanisms where they can make sure that they limit access to who can get stuff on and off the queue. That's the good side. The stormy cloud side of SQS, that you have to deal with to get the goods. You get the messages mostly in order, but don't count on that. If you expect to make sure you see one message and then another because there's some dependencies, don't. That won't work. Don't even try it. You will get multiple delivery because they guarantee they'll deliver at least once, and you can bet that you'll see the same message delivered to exactly the same client more than once, or multiple clients at the same time, or even multiple clients across a period of seconds or minutes even, right? So you have to make sure that you're idempotent, that when you receive and process that message on your client side, it's okay to process the same message twice, or you're responsible for implementing some kind of locking to make sure that you don't process it twice if your problem space would have trouble with that. So for example, if it's a long-running job and you're going to come up with an answer x equals 3, and I'm going to put x equals 3 in some data store, it's probably okay to process that job twice as long as there's no side effects and you're going to put x equals 3 in twice. Not a big deal. But if your use case can't handle processing it twice, you're responsible for dealing with it. You will have weird latency issues. There will be funky timeouts. Sometimes it'll work happily and you'll be looking at a few milliseconds to pull something off a queue. Sometimes it'll hang and it'll be seconds. So make sure you don't have sort of timeouts and things that are very locked down, expecting I got to have a 50 millisecond response or else I blow up and start doing failover. It's not that. The tolerances aren't that tight. You'll also have brownouts, so periods where you'll see high error rates or high latency, where you'll wonder if SQS is down and then maybe an hour or two later it'll recover and everything's back to normal. So you need to have very good retry, exponential back off and logic to keep trying until it looks like things are working if you get generic error messages or things you don't quite expect. So you can imagine why adding those things together, it's best for use cases where your jobs are all independent. I can run them in any order. Doesn't really matter. There's no sort of directionality to my jobs. Just get them done. If you have a use case like that, then it's a good fit. Polling can be expensive if you're doing it all the time. So to get something off the queue to see if I've got a message, I've got to go poll. So I hit the API and say, is there anything here for me? No? Okay. How about now? How about now? If you do that too fast and you've got 100 servers polling every 100 milliseconds, it's like $2,600 a month just for the polling overhead. All right. So if you're running a bunch of 2 cent an hour micro instances, it could cost you twice as much to poll as it does to run the servers. So just be careful. You might not want to poll so frequently, or you might want to have some intelligence in your app to say, while I'm getting stuff off the queue, keep polling fast, but as soon as I don't see anything for a while, maybe back off and don't poll so rapidly. Okay? Auto scaling. So we're going to auto scale the EC2 side of things. So based on how much stuff is in my queue, that determines how many servers I want up and running processing the queue. Okay? So in general, you want to set upper and lower bounds, kind of a range, and you only want to react if you're outside of the range for a period of time. So you don't want to make a snap decision and say, well, if the queue has got more than 10 items in it, immediately spin up new servers. And if it ever goes below 10, shut them down. You're just going to be thrashing up and down constantly, right? So to scale up, you're going to want to start servers once you hit a certain queue length, and it stays above a queue length for a number of minutes probably. And say, okay, now I feel safe that I'm probably going to be above there for a while. It's worth the overhead to spin up some servers. And you don't want to scale to 1 million because you got DDoS attacked and go out of business, right? You don't want the $2 million Amazon bill next month. So put some kind of a reasonable cap on that. When you scale down, you could go all the way to 0 if you want. Right? You can completely turn off all the servers. It just takes you a little more time now to spin up and handle any bursting. So you may want to have a minimum threshold and say, well, I'm always going to run a couple of servers just to have a little excess capacity out there. If you want to be a little bit of a cheapskate, or you have I'm on video, right? A CIO like I do, who's going to kind of look at the bill. One couple tricks you can do is maybe you can have your instances actually just self-destruct when they hit the 55-minute mark of your hour, right? Because you're paying for a full hour, whether you use on Amazon, whether you use 1 second of it or 59 minutes and 59 seconds, you get charged for an hour. So you might want to just have those clients kind of sit there and say, well, it's a 55-minute mark. Anything going on? No, the queues are all empty. I'll just wipe myself out and not get charged for another hour. On the flip side, when you go to scale down, if kind of your control says, we don't need you anymore, go ahead and shut down, the client can say, well, I've only been up like 14 minutes. I'm going to keep staying up just in case because it doesn't cost me anything. I'll wait to the 55-minute mark and then shut down. So a couple little cost-saving tips. If you got a lot of servers, that might add up to something interesting. Okay, so setup time, kind of the natural enemy of cloud bursting. Right? How much time does it take to spin up a new instance and get it ready to go to do some actual work? Because I have to go start the instances, so acquire the virtual resources. I got to put it on my load balancer, ELB, or whatever to get it sort of in the rotation. I might want to put it in a GSLB, global server load balancing, like from Dyn or somebody, to scale if I've got sort of high demand global usage and I want to have people all over the world automatically kind of look up my site and get directed to the closest geographic server. When I spin up new instances, if it's the first instance, maybe in a new data center, a new region, I might want to hit the GSLB's API and say, put this guy in your rotation. or maybe do that automatically through some sort of monitoring scripts. So I get higher performance, better scalability, but it comes at a price of complexity and cost. Now I need to have a contract, etc., and I get this new free bonus latency because there's time to live cache for the DNS lookups on browsers and OSs and proxies, etc. So even if you make one of these instant API changes, don't expect people to get routed to that new box instantly. It could take minutes or maybe an hour even before you get kind of directed over there. So additional lag time. All right, I might also have to install my software stack if my image, like on EC2, doesn't already have everything on there. Maybe I'm using Chef and I want to fire it all up from the ground up every time I boot, which is generally a good practice. That's extra time. I need to launch all the components in my stack. I need to load my code. Maybe I've already got the code on, or it'd be better to pull it out of my Git or get it from some repo so I always get the latest, greatest production-ready code whenever I deploy automatically. I need to load my data, anything that this instance needs to know in order to do its job. Maybe I need to pull from S3, maybe I need to go download it. Wherever I need to get my data, get my data. I want to pre-cache the key data. So I want to warm up my memcached or my proxies or whatever I'm using, run some synthetic transactions, do something to get it really primed and good to go. Then I need to pull the job queue. Okay, SQS, do you have anything for me to do? Yeah, okay, I do the work. Then I'm going to put the result on the response queue. And then somebody in-house is going to pull the response queue and get the result off of it. That's a lot of overhead work. It's stuff we got to do, but we don't have to like it. You kind of make faces like that as soon as you look at the list. I think that's a long time to wait. And we'll look at some of the details of this later. Another complication is you've got to synchronize your private and your public work queues. Right? If you're doing this in-house, you've got SQS and Amazon. You may have your own set of queues, and you want to coordinate those and keep them secure and happy. And ideally, if your jobs are independent, that's pretty easy. If you need some extra coordination, if you've got multiple queues, multiple passes, you've got item potency issues, maybe you need to deal with partial failures, that error handling gets pretty nasty. So again, if you can avoid it, don't have any dependencies and make these jobs sort of self-contained, independent chunks that can go wherever. It makes everything easier. You also have to deal with latency spikes. If you're in EC2, you're going to deal with every time you call an API, it could return practically instantly, or it could take 2 or 3 seconds. You never know. Every time you hit a disk, it could be instant, could take a while. You don't know. When you pull a queue, it could be instant, could take a while. Sound familiar? Sound like a broken record, but don't expect any particular really fast times when you're setting timeouts or failovers or anything else. Make sure you have retries. Make sure you use a little bit bigger buffer than you would for your in-house use when you have total control over those servers. You have to worry about SIDS, sudden instance death syndrome. Anybody run into that? Right? When you start it up, an instance might start, and then where the hell did it go? I just started it. So it could die before it even finishes starting. It could die after it already looks like it's up, but you can't SSH into it. Or it looks like it's up, it is up, you SSH into it, and it's not there. Or it's up, you SSH into it, it is there, and it won't do work. You get all kind of really interesting things that can happen. So be aware of that and bake in that extra time. So this might cause you to start a few more machines than you really need to make sure that the ones you get are good and ready to do real work. Or you can kind of just say, well, I'll test it, and if it's bad, I'll just throw it out and create a new one. But that adds to your startup time. And so the best debugger, and oftentimes, is don't even try to SSH, just shoot it in the head. Right? That's could be your first response to anything that looks weird at all. Just terminate with severe, extreme prejudice. Right? And if you feel a little bit more generous, you don't have to whack it so hard. You can just reboot it. If it looks like it's on fire, hit the reboot button, see if that helps. All right. Okay, so before I jump into the specific solution, our case study, I want to give you a quick rundown of acronyms in case they're not all familiar. EC2 is where you get your servers. S3, your disk storage. ELB is a load balancer. SQS, where you put your messages on the queue. VPC is virtual private cloud. So this is a way to start up instances that are a little bit more network controlled, so you can determine IP address ranges and what they can see, and you can make them sort of part of your environment, including an optional hardware-based VPN. So you can make them essentially your own little isolated network attached to your data center. So all those are options for security, privacy. There's also simple notification service, simple email service, relational database service, elastic block store. They like their acronyms. And in fact, I was just at the location a couple weeks ago, and I got a couple pictures of their whiteboard. There's some more coming. So you heard it here first. The object manipulation graph API, the web technology framework, and the real-time file manager. So you'll probably see those coming soon. Just watch your newsletter. Okay. Our specific use case, big data in sort of our use case is all the open source in the world. Right? Because one of the things we do is open source scanning. So we help enterprises figure out what you've got, what's in your IP, what's open source, what are the associated licenses so you know how to comply with them and don't run into issues. So for governance purposes or even technology to know what versions you've got so you can deal with security patches, et cetera, we do scans. And so that in order to scan, to say what you have, we have to have some database of all the open source packages, all the versions, every single line of code to match that with what you've got and tell you what you have. So a lot of metadata, a lot of code, many terabytes, not going to fit in a relational database. So we're based on Hadoop, HBase, Solr, good stuff like that. And we need real-time access and long-running complex batch jobs. So that's kind of the context. And solution architecture looks like this. We have Nginx and Unicorn. If you're not familiar with Nginx, like an Apache competitor, Unicorn's like an app server for Ruby on Rails apps. So we have Ruby on Rails. It kind of takes the front-end scan request coming in, puts in some metadata information about the customer, things like that in MySQL. So we do have a relational database. And we use Redis and Rescue. Anybody not use Redis or not familiar with it? Everybody is, or you're afraid to admit it in public? Either way, okay. Data structure server, really good for fast atomic actions. And Rescue is a sort of a work queue concept based on top of Redis for Ruby apps. So it's a way to put a bunch of jobs in local memory in a local machine and then process them pretty quick. Over 100,000 writes per second on a laptop class machine, so pretty fast. So we have the rescue workers sort of pulling Redis, getting jobs to do, looking up, hey, Solr, do you have in my search index, do you have something that looks like it matches this? If you do, I'm going to go hit the Stargate, which is a RESTful front end for HBase, which stores all my bulk data, all the open source, the actual files, all that massive many, many terabytes of content. It can pull the full details out of there and then do a deep dive comparison to see what you have, what we think you have, and see if there's really a good match. That's kind of the concept of how the scanning works. And then we put the results back in MySQL so the front end can process it. And we also have a Maven client that can do some of this stuff. Okay, so on the Cloudbursting side, so if we get too much stuff too fast, we want to be able to spike out to Amazon. We get a bunch of scans. What do we do with them? So I know that's probably a bit of an eye chart, so we're going to zoom in. So when a new job comes in, if you can read that, first thing we do is say, is this job sensitive, or do I have a shallow queue? So if it's sensitive, meaning maybe I've got a customer that says, I don't want anything going to public cloud, it makes me nervous, fine, we can flag all your jobs as sensitive. Or if there's some other special thing we're doing where we have compliance or regulatory concerns, we can flag that, make sure it always gets processed in-house. Or if we have a shallow queue, we're not doing a lot, we've got internal capacity, why pay for public cloud resources, let's just do it. So if either of those is true, we put on a local job queue in Redis and Rescue, have a worker pick it up and just do it, okay? But if the queue gets too deep or taking too long and it's not a particularly sensitive job, it's eligible to go out. So we put it on the outgoing job queue, which gets picked up by what we call kind of a liaison worker. And this guy's job is to pick up the internal job off the queue and essentially do a secure transform on it. So it's going to strip off customer information, anonymize it, encrypt the things that need to be encrypted, and basically get it into an independent little package that means essentially nothing to anybody outside of our firewall. There's no way they could really take any data out of that and make it meaningful or associated with any customer. Okay, so we put anonymous IDs in it, good stuff like that. Store some local state about it. Then we have the EC2 workers pulling that SQS queue and say, what do you got for me? Okay, I have some work. I'm going to crunch the data, look in my local indices and things, and we'll talk about how that detail in a few minutes. Puts the response back on an outgoing or incoming, depending on how you look at it, SQS queue with the results. And those will get picked up by separate liaison worker that now sort of de-anonymizes it, looks up the generic IDs we stuck in the outgoing message, reassociates them with the customer, plugs in a bunch of data where we sort of repopulate everything and get it ready, and then put that in our local queue to be finalized. And so depending on what the EC2 worker was able to do, the job could be completely done already, and the local worker says, oh, you got the final answer. Okay, I'm done. I'll just put it in the data store. Or it could be that there wasn't quite enough information available in EC2, maybe because we didn't have all the data in the public cloud. Maybe it was partially processed, and it speeds up. It did some of the work, so the local guy has to do less. Or maybe it's, I looked and I tried really hard. I couldn't do anything with this because you have all the info you need in-house only. So just do the work, all right? And so we kind of get back to the complete picture. That's kind of the concept. So one of the reasons why you may not have all the work, and this is just the word so you can have the slides later of what I just said. One of the reasons you might not be able to answer all the questions is because it's not easy or cheap to have all of the data if you've got big data out in the public cloud. So for example, if you're going to store 100 terabytes long term, it's $120,000 a year to rent some disk space that you could buy one time for under 20K. So you may not want to put all that data out there and leave it all the time. Or you may not want to try to keep it in sync with what you've got in-house. Or you may not want to try to burst it in and out because it's just too big to move fast. Right? So there's lots of reasons why you might not want to do that. So be careful where you spend your dollars. So what we do is we can store a full index of the data compressed in S3. So it's a very small fraction of the total volume. And what that lets us do is be able to search to see if we have a match against anything by only storing a very small piece of the thing. So you have to do some clever work there with Solar or whatever you have, and you have to be careful about how you index, how you compress, but you can make that work. And then we also store what we call a cache of the most likely matches out in S3, again compressed, well under 0.1% of the total corpus of data. So it will fit on an individual instance, not that much. You're talking about 100 gigabytes or less of kind of data. That will enable us to match on the vast majority, the at least 80, 90% use case of scans that we're going to do of things we'll really find in the wild. Which means we can process a lot of jobs from end to end entirely in the cloud without needing any local resources to sort of finish up, okay? So the way that works is the instances pull down this information when they boot. So as they start up, they pull it out of S3. Yeah, it does add to the setup time, but it means we can process a whole lot more jobs out in the cloud. And if you've got really big data and you're going to push your limits, which we may run into pretty soon, if even your index or your compressed little piece of your data won't fit on an individual instance, you may have to partition. So in our use case, there's a number of ways to partition. We could split up by language, for example. Maybe Java, everything Java related goes in one sort of queue, one data set, one index, and we have other languages go somewhere else. One nice thing about splitting that up is if you have different queues per language, say, in our world, it takes a lot longer to process a C file than it does a Ruby file because there's a lot more lines of code, and they tend to be boilerplate, so they look the same as everything else. So we might want to look at the length of a queue being X for a C file actually needs more workers to process than the same length queue if they're Ruby, right? So we get a little more fine-grained tuning and flexibility there, okay? One way to handle that is you might still want to have one incoming queue. So your client side, you're in the data center side just says, do the work. I don't want to know anything about the partitioning. And then you just have a sorter job on the EC2 side that sits in front of everything else and says, what kind of work are you? Okay, put it in the right queue to go get processed. So that way you isolate that determination logic. So pros or cons, you do have to write the sorter job, but you get more flexibility for auto scaling. You do have to guess correctly when you split or partition, which is kind of a pain. You have to get that a little bit right. And then there's more moving parts to manage. Okay? So auto scaling on the EC2 side, probably want to scale on SQS queue length. At least that's the easiest way to start because it's sort of baked into Amazon auto scaling. You can scale by queue length. In our case, we could get random bursts of over 1 million jobs that happen almost instantly. And there's no certain time of day, day of week. There's no rhyme or reason to it. We can't predict it. So we kind of want to scale in batches of grab me a bunch of machines at once, because otherwise we just continuously add and add and add little bits and pieces. You want some bake-in time after you do scale, because you may have a bunch of very small jobs or a few jobs that take a long time to process. So you probably don't want to scale up and then scale down real quick. You want to give it a little time to see what happens to that queue before I go messing with it. Right. Ideally, you'd scale on expected processing time. So you could determine not just by length of queue, but by what's actually in the queue, how long it's going to take. So maybe you can, in our case, a customer scan might be, go scan these 1 million files and tell me when you're done. So we might want to look at it and say, well, how long is it going to take for that customer to finish end to end, these sort of the macro job around these 1 million little jobs? How long is that expected to take? Okay, we have SLAs. We're going to try to meet that in an hour or so. We can do the math and figure out how many machines we want to spin up right away. So that would be ideal. We're not there yet. I wouldn't recommend trying to start there. You can easily start on queue length and then adjust. And again, don't forget the upper limit. You don't want to deal with your CIO later. On the security side of things, my little castle, you can see he's got moat and more walls than one, because you never want to just have the crunchy outside with the soft, chewy center. When you're talking about security, you want broken glass all in between. Right? You don't want to make it easy for somebody. So HTTPS everywhere when you're talking to AWS or anything external. We also encrypt the payloads and anonymize them. And we use encryption keys that we actually pass to the EC2 instances with Cloud Init on startup. So the keys are never stored anywhere on Amazon. They're never outside of our firewall. And we pass a randomly generated key in. Say, here you go, Mr. Instance. By the way, don't put this on disk or anywhere else. Keep it in memory only. And decrypt jobs coming off the queue and encrypt when you put the answers back on, and nothing ever hits disk. All right, no results hit disk. The instances are essentially stateless except for those generic caches and indexes I talked about earlier, which is nothing customer specific. All right. Some jobs just aren't suitable for the public cloud. So you might have sensitive data. You may have the scale of data is just too big. Maybe I have to have it in-house because it would cost me a fortune to put it in the public cloud. Maybe I've got compliance issues or other issues. So you can just flag these and stick them on your in-house only queue, right? So you can easily determine what goes out and what stays in. Now the corollary to that is some jobs are much better done in the public cloud because they have way more available bandwidth. They have a global presence. They have massive scale. So some jobs you want to put only on the public cloud. So what I'm saying is this is another tool for the toolbox, just like you can use multiple databases, NoSQL, languages. Think about this as yet another switch. Now I have the ability to use public or private cloud. So put that in my architectural kind of toolbox and choose the best one for the job. Okay. So a lot of moving parts here. So you're going to need to test it. You're not going to get it right the first time. So I highly recommend you try to use realistic data volumes and production data if you can. Ideally, you could even sort of snapshot, record production data, and then play it back later against your staging system, which hopefully is exact snapshot code and structure-wise as production, and see how it performs. See if you're happy with the setup time, if you're happy with the latency, etc. And you've got to introduce the chaos monkey, right? And randomly shoot stuff in the head and see what happens. Make sure you don't drop messages. Make sure that things aren't taking horrendously long to process if some little glitch happens in the middle of this flow. Some considerations on bandwidth, for example. You're sending a lot of jobs. If these jobs are big, right, it could take time to send. That's bandwidth. You got to get the results back. You've got to manage all those queues and monitor them. So you might want to look into AWS Direct Connect if you need a really big pipe. You can get dedicated direct 1 to 10 gigabit per second to Amazon. So that's a possibility. Startup time can be minutes. So again, use case specific, whether it works or not for you. It's not free, but it's also not super expensive to get started, right? Because everything on Amazon is basically pay per play, and the raw dollars are very, very small. It's a 1/100th of a cent for this and 2 cents for that. It's not till you get to scale where those numbers mean a whole lot, so it's very easy to experiment and prototype. Security, if you are pretty security conscious, set up a virtual private cloud. That, again, is essentially free with EC2, unless you use the hardware option. So the software version's free. And you can restrict some of the Amazon access to say, for example, I only want access to these S3 buckets from my virtual private cloud, or this range of IPs. So you can take advantage of that too if it makes you feel better. Now, there are a lot of moving parts. So on the monitoring side, something we built, a pretty simple little thing based on getting counts out of Redis and Rescue and counts out of SQS to be able to see what's going on visually, sort of real time. Something called Zappa. Anybody familiar with Zappa? No, wow, nobody. It's a little highly opinionated framework based on Node. It actually sits on top of Express, which is a Sinatra-like web framework for Node.js. And it basically makes it really easy to do things with WebSockets and socket IOs and have a whole bunch of listeners attach and send out lots of data, like live ticks or updates of queue counts. 100 a second, no big deal. Tens of thousands of connections, not a problem. And you can do all this in CoffeeScript. Use high charts for client-side charting. So this the little tool that I wrote is 100% CoffeeScript because it'll even generate your HTML and JavaScript and everything from CoffeeScript. Under 500 lines, including all comments, blanks, and everything else, and it is crazy, wicked fast. So it's something to look at if you need a kind of a rapid monitor with live charting. It can be nice. So some final thoughts. Use the best tool for the job. There's a lot of open source out there, a lot of different VMs, a lot of different clouds, public and private. We use all these things, and you can see how many languages. There's Ruby, Java, JavaScript, CoffeeScript, C, C++, just in that list, right? And they can work together. They're complementary. It's not a one-size-fits-all. Use the best tool. Don't force it, right? Don't use a public or private cloud because you want to or because it sounds cool. Don't use NoSQL just because it sounds cool. Use it because it's the best fit for your architecture or best fit for your use case. You'll have time to play with the other stuff later. There's always more to do. And finally, experiment and expect failures. You're going to fail. Hopefully you'll fail a lot because that way you'll learn faster and get it right quicker. You don't have to take your entire problem and cloudburst it. I think that's another important message. You can carve off one little piece and say, well, that thing right there looks, that lookup or whatever, that's kind of killing us. Can we partition just that? And when we get in really high load or expected times a day when we're going to have problem or time of year, can we pre-stage or pre-scale that or somehow leverage the cloud just a little bit? Maybe a security insensitive area or something that people won't freak out about. Get some experience on your belt, get some early success, and then look at maybe a little bit bigger picture. And last piece of advice is design for the 1 in a million occurrence, because when you're dealing with the cloud and you're dealing with big data in particular, and especially if you put them together, you've got trillions of interactions happening, so 1 in a million happens a lot. So the weird things you don't expect happen all the time. So plan, design for failure right from the beginning, and it won't catch you off guard and you won't have trouble. If you try to ignore that and assume it's going to work about like it does in your data center now, you're going to be very sadly disappointed because it'll go wrong and you won't know why. All right, and that is me. So we have time for questions. 5 minutes for questions. Everybody's dying to get to break. Late afternoon talk. Cookies on our future. No questions? All right, well, thanks.